and thank you for joining us, all 287 of you. If I say something that you don't understand, I'll try to accommodate that. If you write it in on the chat on the side, I can see that as it goes along. And our subject today is the new ISO 22000. So if you are not an ISO 22000 enthusiast, you may be in for a bit of a boring evening. I apologize because we're talking about standardization, which is not the most exciting subject, but I'm going to try to make it as exciting as possible. So just a little background. When ISO 22000 was born in 2005, it was a very, very exciting event for the whole world. And what the people who wrote the new ISO at that point did was, for the first time since 1993, made an attempt to revise the risk-based thinking that was called HACCP, HACCP, and bring it up to speed and make it and integrate it with the language of ISO 9001 and other food safety management systems. So what ISO 22000 did was it took the what we call a food safety risk assessment and integrated it into a food safety management system. And this food safety management system is a triangle that has three sides. One side is HACCP HACCP, risk-based methodological thinking. And then we have the good manufacturing practices side, which was renamed to be the PRPs. And finally, the management of the whole thing, the document control and training and the calibration and setting up goals and policies and blah, 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 anything that we'd call managing a management system, which would be identical for food safety and for other agendas. In 2018, in June, we were given the ISO 22000 new version, which is a revision, and there are a lot of changes in it. A lot of them I really do not like. Some of them I really do like. But I guess if I like it or not, it's irrelevant. We must follow the requirements of the standard. So I'm going to walk you through the major changes. I'm going to get on with switching my slides. So we're talking about the major changes compared to ISO 22000 version 2005. We're now talking about 2018. So buckle your seatbelts. We're going for a ride. The major change in the new version, and by the way, if you are an ISO 22000 certified organization, you will have 3 years to make the transition. In 2021, the 2005 version will become obsolete, and only 2018 will be recognized. I do recommend not waiting till the last minute and getting organized as soon as possible. So the first major impact that we're going to feel when we look at the new standard is its alignment to the high-level structure of ISO. And in 2018, with the publication of the new ISO 22000 and the brand new ISO 45001, we for the first time have aligned all four of the leading management systems that ISO publishes. ISO 9001 for quality assurance, ISO 14001 for environmental care, ISO 45001 for occupational safety and employee health. And please pay attention that the 45001 replaces what used to be 18001, which was not an ISO standard, but it was aligned with the 14001. That will become obsolete, and 45001 will replace it. And of course, the star of the evening, ISO 22000, 2018. And the high-level structure alignment means that they have the same clauses that are parallel to each other, often redundant with each other. And when each standard deals with its own issues that are specific to its agenda, then there'll be a divergence from each other. But everything that is generic in standards like document control, policy setting goals, interpretation of results, corrective actions, and so forth and so on are all identical in all four standards. That's the major change. And one other change that is exciting is that in the ISO 2000 and the ISO 22000 from 2005, the food for animals was not included, and it is now included. Animal food and feed are included in the scope. Let's just go back there for a second. If for some reason the standard writers use two different terms, the term animal food is used for food that is intended for animals which are not part of the human food chain. So it would be pet food, or maybe food for animals that are kept for hobby, not to be eaten. And when you talk about animal food, then of course the relevant hazards will be hazards to that animal, to its health and well-being, and not to human beings, because those animals are not intended to be eaten. That being said, if we talk about pet food, for instance, then of course we expect the management system to include hazards to human health, that because we keep these animals in our houses, and we are close to them, and they're part of our families, and there have been many food incidents, food safety outbreaks that have been associated to pet food. Not the pets becoming ill, but the owners becoming ill, what we now call the pet parents. And on the other hand, feed is what the term used for food intended for food-producing animals, in which case the hazards will include hazards to human beings that are eating those animals or their produce. So milk, meat, eggs, poultry, and so forth. So now that is now included in the scope. It hadn't been in the previous version. Okay, the next thing I want to talk about is terminology. The chapter 3 of the standard has dozens of definitions for terms. One thing I do not like at all that they did in this version was they are now, because of the high level structure, all the terms have been arranged by alphabetical order, which makes no sense at all. But that's just the way it is. When we translated the standard to our language, we made a local addendum, and we organized them at the end in logical order like they were in the previous version, because if you want to read through the terms to learn food safety, what they mean, then it makes no sense going through alphabetically. So the new terminology includes many different terms. I'm going to go through the most important ones. Okay, 2005. This is the previous version. The food safety hazard was defined as biological, chemical, or physical agent in food or condition of food with the potential to cause an adverse health effect. Pretty clear, pretty straightforward. Well, here comes 2018, and the standard has omitted or condition of food. So now it reads biological, chemical, physical agent in food with the potential to cause an adverse health effect. I want to pause on this because there's one of the changes that I do not like. The reason I do not like it, I'll give you an example. If I was recently visiting I'm going to clear my throat for a second, hang in there. I was recently visiting a supplier, a private label supplier of pet food for one of my customers. I asked them, I looked at their risk assessment, and I asked to see if they had identified in their food safety management system a condition of absence of an essential nutrient, because there have been cases in human food and in pet food intended to be complete foods of an absence of a nutrient, which can cause severe adverse health effects, including death. And they had not identified it as part of the food safety management system. And the reason they said it is because, well, a food safety hazard is defined as a biological, chemical, physical agent in food. And if we have a lack of vitamin B1, for instance, it's not something in the food. It's not a contaminant. So it's not part of the scope. Which, if I was using the previous definition, that would be a condition of food. Give another example. I audited a company that makes lunch meat, and they have a secondary inhibitor nitrate in the product to prevent proliferation of bacteria later in the product's life. Well, there was a case where an employee, because of a human error, did not add that specific food additive, and what happened was the product went bad on the shelf. It had to be recalled. Now, this is a food safety hazard, but it's not something in the food. It's something absent from the food. Another example would be if we have a product that's being packaged in a sealed package that's supposed to be 100% sealed, and there's a problem with the seal. Well, that would not be identified as a food safety hazard either, because it's not a biological, chemical, physical, and which is wrong. But that's what the standard says. The way to get around this, if you are an auditor, or if you want to, if you do want this to be in your food safety management system, but still don't want to work against the definitions of the standard, well, if we were to look at the whole standard, all of these, the whole food safety management system part of ISO 22000 lives in Chapter 8, which is the chapter of, we're going to get to it in a second. It's what we call the production and processing chapter. But Chapter 6, the planning chapter, is identical to ISO 9001. And the big new thing about ISO 9001 starting 2015 is the requirement to conduct an assessment of hazards and opportunities, to do a risk assessment and an opportunity assessment. And if you do that according to the requirement of the standard, and even if you don't have a food safety management system, it doesn't matter, even if it's not a food company, well, then I would ask them, have you not identified the lack of or the absence of as one of your hazards, and I'd attack it through that item, not through the HACCP. But that's my recommendation, is to ignore this change and to continue to understand that a food safety hazard is anything, including condition of food, which will cause an adverse health effect. I'll give you one more example. If I'm manufacturing, let's say, soft drinks, and I make a 6-pack, 1.5 liter bottles, and a 6-pack, that's a 9-kilo product that people pick up in the supermarket, and it has the handle. Well, if I'm walking from the supermarket to my car with that product and the handle tears and the product injures my foot, I consider that a food safety hazard, because I was harmed. My health was, my toes were hurt. Sometimes it could be severe. Because the product failed, because of a fault on the product. True, it's not bacteria, but it is a food safety hazard, and that also is what we call a condition of. Okay, so moving along. New 2018 term is significant food safety hazard. And what it says is that a significant food safety hazard is a food safety hazard identified through the hazard assessment, which needs to be controlled by control measures. Needs to be controlled. So this is the classical, it was always there, but it didn't have a name. So our risk assessment always said that we have to, when we do a risk assessment, we identify our hazards, and then we do a risk assessment, and then we choose which ones of them are significant and which ones are not. So now it has a name. The excitement here is in the use of the word control measures, because it now has a new meaning. So follow this carefully. A significant food safety hazard needs to be controlled by control measures. Okay, remember that. We're going to talk about control measures in a second. So what is a control measure? Well, in 2005, a control measure was an action or activity that can be used to prevent or eliminate a food safety hazard or reduce it to an acceptable level. Not necessarily critical. Because you said it says to eliminate a food safety hazard, any food safety hazard. So what we would do is we would map out all of our control measures, all of them, even the ones that are not going to be part of the critical control measure system. They're not going to be CCPs, they're going to be OPRPs, just regular control measures. That was in the 2005 version. Well, the new version says, no, we're talking about something else. This is new. Okay. By the way, Hin Waima, you asked a question. If the ISO 20000 requires an applicant to company to prepare a specific manual, the answer is no. And it's also not required for ISO 9001. So if somebody told you that 9001 requires a manual, it doesn't anymore. It did up until 2015. So the new control measure is different. It's an action activity that is essential, not can be used, to prevent, not eliminate, a food safety hazard or reduce it to an acceptable level. Now, I made a mistake here. I apologize. If you have to put between the word food, between the word A and food, significant food safety hazard. So control measure 2018 is an action activity that is used to prevent a significant food safety hazard. So we have three things that are new here. One is that the control measure is now essential. So all other measures that have not been identified as being essential are not control measures anymore. They don't have a name. So you can call them whatever you want. Call them measures, call them uncontrolled measures. I don't know what you want to call them, but they're not control measures anymore. So if I have a magnet, a sieve, a metal detector, and only one of them is going to be chosen as a CCP, the rest are just going to be control measures. They're not going to be called control measures anymore. They'll just be regular measures, I guess. That's one major change in this term. The other major change is that the new standard does not use the word or eliminate anymore. So there's no elimination in all of the definitions. It's to prevent or reduce. So I guess if you do something to an acceptable level and the acceptable level is 0, then that's elimination. And the third major difference is that a control measure is used for a significant food safety hazard. That's the word that I forgot to put in here between the A and the food, significant food safety hazard. Many changes regarding the CCP and the OPRP, and I'm going to talk about this for a second before I go into the continuation of the slides. Just want to give a background on this, talk about this for a little bit. Because ever since ISO 22000 was published in 2005, the new term that had been invented called the operational prerequisite program was misunderstood. It was poorly interpreted. There was a lot of ambiguity and a lot of misunderstanding about how to use it. And 2 years ago, I gave a webinar on to try to help clear this up. And it was my understanding that the writers of the standard intended an OPRP to be an operational prerequisite program, meaning that that it is a PRP that has been identified as essential, and therefore it's now an OPRP. So, my understanding was that if you have a control measure that has a potential of being a CCP, for instance, if we have, and the best example is, for instance, a sieve or a filter. So before the invention of ISO 22000, when we're still stuck with the traditional HACCP, then of course a filter or a sieve could be a critical control point. And when ISO 22000 came out, it automatically became CCPs. They stayed CCPs, but some organizations thought maybe that's what they mean by an OPRP. And there was confusion. What they did in the new standard was they tried to clear up that confusion and make it even more confusing. And I think that's unfortunate. Instead of sticking with the original meaning of an OPRP, what the writers of the new standard did was gave in to the people who interpreted it wrongly and now made it official. So I'm going to explain that when we get to it. I'll give you an example. So in 2005, a CCP was a step at which control can be applied and is essential to prevent and eliminate a food safety hazard or reduce it to an acceptable level. This has not been changed ever since Dr. Howard Bauman and Dr. Paula Chance in NASA in Pillsbury invented HACCP. It was the same in 2005. A step in the process, a step at which control can be applied and is essential to do one of three things: either prevent, eliminate, or reduce. Now I'm going to show you the 2018. Don't get scared. Okay, I messed it up a little bit, but I want you to be able to see the 2005 in the background. So first major change is it must be a step in the process. Now this was clear before, but if it wasn't clear at all, now it is. So if I had any question, as for instance, hand washing and sanitizing, is that a step? Is that a step at which control can be applied? Well, some people say, yeah, of course it's a step. Well, now the writer's going to say, make it clear that it is not. It must be a step in the process. Otherwise, it will not be a critical control point. And not control can be applied, but a control measure is applied. And I want to remind you, a control measure is something that we are applying to a significant food safety hazard. So it must be applied. It means that a critical control point will always be against a significant food safety hazard, and it's going to be emphasized in a second. So instead of saying control can be applied and is essential, it says a control measure is applied to prevent or reduce a significant food safety hazard to an acceptable level. So up till now, this is no drama here. The drama starts with the red part, which has been added in 2018, saying, and defined critical limits and measurement enable the application of corrections. Now, if we have a sieve that in the past was a CCP, it can't be a CCP anymore because it doesn't meet the new definition. It is a step, the sieve is a step in the process. It is a step in the process where a control measure is applied to a significant food safety hazard, and it can reduce that hazard to an acceptable level. However, for a sieve, we don't use defined critical limits and measurement. We use the judgment if the sieve is intact or not. So what we'll do is, when monitoring a sieve, we'll do a visual inspection and look at it and say, okay, well, the sieve seems to be fine. It's perfect. I've looked at it, and I just write in my little notebook, the CCP is under control. And we do this once a shift, once an hour, once a day, whatever frequency we've decided to do it. Well, now we can't call that a CCP anymore. Only those steps in the process where monitoring yields a number, a measurement, temperature, time, chlorine solution, Gauss, pH, a number that we're going to be derived from the measurement, then we can call it a CCP. So anything that's being observed is not a CCP anymore. Big change. And this is because of this big change. An OPRP in 2005 was a PRP. And as soon as we understand it's a PRP, then anything that's not a PRP couldn't have been an OPRP. So anybody from 2015 to 2018 who called anything that's not a PRP an OPRP was making a mistake, because it's not a PRP. So it used to be that an OPRP is a PRP that was identified by the hazard analysis as essential in order to control the likelihood of introducing food safety hazards, blah, blah, blah. And the way we understood this, most of us, was that we now have a term that we can use when we have a critical PRP, because the CCPs are critical steps in the process, but everything around the process, the PRPs, the prerequisite programs. Now, the definition for a PRP has not changed. It is still the same. A PRP is a prerequisite program. It includes hand washing, sanitizing, SSOPs, SPSs, pest control, glass control, metal control, purchasing practices, cleaning, sewage, keeping the building, hygiene. Those are all of our prerequisite programs, our PRPs. And if any one of those elements in the past was identified to be crucial, for instance, monitoring glass and brittle plastic, or sanitizing hands, or preventive maintenance of equipment, if any one of those had been identified in 2005 as being critical, then we could call it an OPRP instead of just a regular PRP. Well, what the writers and standards are now saying is something a little bit different. And try not to get confused. At the bottom line, it's Not that confusing. 2018, they have totally removed the previous definition of an OPRP and written a whole new one. Okay? And the new one says that an operational PRP, an OPRP, is a control measure. And remember what a control measure is. A control measure is any action that we can use to reduce or prevent a significant food safety hazard. So control measure or combination of control measures applied to prevent or reduce a significant food safety hazard to an acceptable level. So up until now, this is an exact same definition as a CCP, exactly the same, without the step in the process. And the addition explains what they mean and where action criterion and measurement or observation enable effective control of the process or product. So no more critical limit and no measure, which is mandatory for CCP. To make sense of this, of everything I've said till now, the bottom line is as follows. If any control measure now is anything that we do to prevent or eliminate or reduce a significant food safety hazard anywhere, anyhow, they are classified into two names, either CCPs or OPRPs, all of them. If you are a step in the process and you are being monitored regularly and you are yielding a number, a measurement to make the decision if the product is under control or not, you are a CCP. Any other control measure that does not meet that description is an OPRP. Okay, I'm going to say that again because it's just to make sure we're clear. If there is a control measure that is a step in the process, and it's essential, it's a control measure because it's now essential to reduce or to prevent a significant food safety hazard, and monitoring yields a number, a measurement, then you are a CCP. Anything else is an OPRP. So we can now find two different types of OPRPs. The first type of OPRP which will be those OPRPs that are steps in the process alongside their CCP friends, but they're not measurable. They are observable. So they're now OPRPs. So along the process, as we go through the process, we will have steps in the process that are CCPs, and steps in the process that are OPRPs, and steps in the process that are nothing. In addition, if you are a PRP, in other words, you are being applied not as part of the process, but around the process, like hand sanitizing, like preventive maintenance, like pest control, glass control, and you are crucial, you are essential to reduce or prevent a significant food safety hazard, you're also an OPRP. And that is the old version OPRP. So that hasn't changed. That was always an OPRP. But now it's also an OPRP in the process. So Mel, you're right. It is not necessary to the last point in the process where you can control the hazard. Okay? So this is not true anymore. It's not the last one. I'm answering Mel Morris, who made a comment, and the answer is no. It's not necessary to be the last point. What is necessary is to be the most effective. So if I do have a few control measures along the way, and I want to choose which one's going to be CCP, then I will choose the one that is the most effective, not necessarily the last one. And that makes a lot of sense. Because if the hazard coming in is a hazard that's being introduced through raw materials, I wouldn't like to keep it in my plant all the way to the end. I'd like to eliminate it as soon as possible. So sometimes I will use the last point, sometimes I won't. And Eric is saying, so what do we call metal detectors as a CCP? Good question, Eric. The jury is still out. It's arguably a CCP because using the dummy probes, metal, ferrous, non-ferrous, and stainless steel probes to monitor your metal detector will derive a decision that is a measurement. So it is under 2.5 millimeters or under 4.5 millimeters. So you can still call it a CCP. Some people will argue, no. That's an observation, so it should be an OPRP. Well, you know what? It doesn't make a difference. You can call it either a CCP or an OPRP. You're still going to be doing the exact same things to it. So as far as that, so the jury is still out. So no, John, no. John's asking if every PRP is an OPRP. No. A lot of PRPs are there because they're important, just like a lot of control measures that in the past weren't critical or still aren't critical. We have them because they are part of the whole idea of making food safer. So everybody washes their hands all the time. In most occasions, that's not critical, hand washing. People who wash hands in warehouses and in raw material areas, it's not crucial. Only those people who are touching ready-to-eat product with their hands, for them, hand washing will be an OPRP. For all of us, it'll be a PRP. So not all pest control is an OPRP. A lot of PRPs, most PRPs are not OPRPs. Okay, so let's now go into the standard. Oh, sorry, I owe you an explanation for this. This new term, action criterion, has been introduced in 2018. It replaces the critical limit for OPRPs. Because OPRPs don't necessarily have a real measurement, don't necessarily have a measurement, then they get an action criterion. It's a new term. It's the same thing as a critical limit. It means a measurable or observable specification for the monitoring of an OPRP. So still, even if you have an OPRP that's being monitored with a measure, for instance, you're using an ATP swab to verify cleanliness. Well, that's part of your PRP. That's not a step in the process, so it has to be an OPRP, the cleaning, but you are measuring when you do the monitoring. So it could be measurable or observable. For instance, our glass covers, our light cases are intact. That's observable. Or our sieve is intact. That's observable. So that's an action criterion. Okay. Now, this is just a note that I quote from the standard. The standard has notes. It says an action criterion is established to determine whether an OPRP remains in control. And it distinguishes what is between what's acceptable and unacceptable. And if you read the light font, it explains what acceptable and unacceptable is. Acceptable is criterion met or achieved. That means it's operating. Unacceptable, not met or achieved, is not operating as intended. So it's the same thing as a critical limit, but it's not a measurement necessarily. It could be an observation, or it could be a measurement offline. So, So, Taro Ora is asking, storage temperature finished products is CCP or OPRP? Storage temperature would be an OPRP because it's not a step in the process. If somebody calls it a CCP, they're a champion. It makes no difference. And the good news is, as long as we identify a control measure, it doesn't matter what name we give it. It hardly matters what name we give it. We're going to go further deep into the standard and see that there are places where there are clear differences between CCPs and OPRPs. I don't like any of them, but they're in the standard. So let's go on and see what that means. So just a comparison graphic, CCP, OPRP. Let me just change my transition. Can I do that? Hang in there for a second. I don't like the way it's Let's try this. Better. That's what I wanted. Okay. That's a better effect. There's a chat bar. Okay. You still with me? All right. So just compare CCPs with OPRPs. Okay. So a CCP is a step in the process. An OPRP is a control measure or combination of control measures. It doesn't say that it's not a step in the process. It could be, but it doesn't have to be. A CCP must be. Second difference, CCPs are defined when we monitor them according to critical limits. OPRPs according to action criteria. CCPs, we use measurement only. OPRP can either be measurement or observation. So anything that's observation is not a CCP anymore. And finally, with CCP, it says that the CCP will enable correction And what an OPRP says is it enable control of the product or process. Now, this is a real important difference between them, and one of the ones I don't like, but we have to learn to live with. Because we're not measuring something, there may be cases where we're talking about control of the product or process. And the way we understand that is when we have a violation of a CCP, then we immediately stop, and we can, and our reaction is immediate. We know that we had a violation within hours, and it can be corrected. Sometimes an OPRP observation will happen at the end of the day, and it will be and it won't be as timely as a CCP. So then we don't say we can make a correction. We can just control the product or process. What this means is, if we go into detail, truthfully, it's the same thing. But some people argue that if you're doing it at the end of the day or maybe the next day, then it's not a correction. Still, the principle that it cannot leave the plant is valid for both of them. If a product has been produced where the action criteria have not been met, or the critical limits have not been met, it's the same thing. It can't leave the plant unless, and we'll get to the unless in a second. And and I do agree with Naron Kai, who's saying, I hope you're pronouncing your name properly, OPRP looks like the preventive control in FSMA. Yes. It's worth making a note that both FSMA and ISO 20000 2018 do not make mention of the term HACCP anymore. And it's a sad moment in history where HACCP has officially been retired. The term HACCP. It's mentioned in, if you go through 20000 and do a word check to see how many times HACCP appears, it appears once in parentheses in a note. It has no meaning in the standard. Same thing with the FSMA. FSMA has replaced HACCP with HARPC, which is not focusing on critical control points, because HACCP is hazard analysis and critical control points. So the whole point of HACCP is the CCPs. Well, both 22000 and FSMA say no, hazard analysis and risk preventive controls. So not just critical control points. And this is a strong message to the industry in general, a very strong message, saying that HACCP is not just about cooking your chicken. It's not just about pasteurizing your milk. It's not just about putting on a metal detector. It's much, much wider than that. It's not HACCP anymore. It's a food safety management system. Okay, so let's move along. Item 8.2, the PRPs. Big change here. When selecting and or establishing PRPs, the organization shall ensure that applicable statutory blah, blah, blah. Same thing. This has not changed. This has changed. Organization should consider the applicable part of ISO TS 20002. This is the mention of this. It's not mandatory, but it should consider. I want to remind you that ISO Technical Specification 20002 series is a way to spell out the PRPs for those organizations that have not developed their own. And it's very similar to the BRC requirements, the FS requirements, SQF requirements, just a list of requirements included in 20002. The great thing I love about 2002 is that it's delivered to us in 5 different formats according to where we are in the food chain. So food manufacturing, catering, farming, food packaging, and feed, 1, 2, 3, 4, and 6. If anybody's wondering where 5 is, 5 has been suspended currently. It is intended for food transport and storage, and maybe it will make a comeback someday, but right now it's not published. And these are all published. These are all available in different languages. So and using the word should, I want to remind you, in high-level structure standards mean you don't have to. Otherwise, it would say shall. So in English, we say should is a recommendation. Shall is a requirement. That's the way the English language works in ISO. Okay. 8.5 hazard control. This is the 8.5 is what used to be HACCP. The 12-step program, 5 preliminary steps, 7 principles. They're all hidden in 8.5. 8.5.1 preliminary steps. Maintain document information, raw materials, ingredients. Nothing new here. This is the same wording. The news is. Wait, I made a mistake. Oh, sorry, there is big news here. Sorry, my mistake. Back up. I want to emphasize something really important here. It says that organizations shall maintain documented information concerning all raw materials, ingredients, and product contact materials to the extent needed to conduct the hazard analysis. This has always been written, no change, but we have a few things that are really interesting, and we'll see them here. So, I don't know why I'm missing a slide. Let me just peek for a second. Hang in there. Okay, I don't know. I'm missing a slide. I'll talk about it anyway without the slide. Okay, so sorry about that. The organization will maintain documented information. What I want to make a point of here is that when we talk about the information needed to do risk assessment, when we talk about raw materials, the new standard mentions 2 things that had not been mentioned before. One of them is the country of origin of the raw material used. So it is part of the risk assessment, and that may have an effect on decisions made by the team. And also the technological origin of the raw material. Is this a material that is it coming from animals, from plants? So if we're talking about things like ingredients like lecithin or gelatin, they could be coming from different sources. That should be identified as well. That's what I wanted to say here. Okay. Okay, hazard identification. That's the first part of HACCP, identifying hazards. Organization shall identify and document all food safety hazards that are reasonably expected to occur in relation to blah, blah, blah. This is not new. This is new. Hazards should be considered in sufficient detail to enable hazard assessment and the selection of appropriate control measures. This is one of the things that I applaud with the new standard, because it was me as an auditor for years, I've been requiring this. And people have been saying, well, you may think that it's important, but it's not written anywhere. Well, now it is. Hazards should be considered in sufficient detail in order to enable hazard assessment and the selection of appropriate control measures. I'm going to give you an example. So here we have an example. People here, they're putting together sandwiches. Hazard identification. So in the 2005 version, you could just write in your Excel sheet, in the identification of hazards, just write pathogens. That's the hazard. Well, and then I would say, hey, you can't write pathogens. You can't do that. Because what pathogens are we talking about? And they'd say, well, that's how we do HACCP. Sorry. Well, now it says you can't do that because this says in the standard. That's not sufficient detail to enable hazard assessment. You can't choose appropriate control measures because there are all kinds of pathogens. So now I'd expect to see something beautiful like this. Introduction of pathogenic organisms resulting from human-hand contact, and then continue to write fecal viruses, fecal bacteria, fecal worms, protozoic fecal parasites. Okay, Staph aureus. Now you're talking. Now you're doing a risk assessment. Without specific reference to every single pathogen that can be transmitted from human hand to food, and talking about it and understanding its likelihood and its severity and its control measures, you're not doing a risk assessment. So it's important for me to, and I'm so happy the standard now gives us auditors a tool to say, hey, I'm not accepting this. It's unacceptable. So no more pathogens, no more foreign bodies, no more bacteria, chemicals, blah, blah. No, specific enough to be able to do a risk assessment. It's going to take you more time, more effort, but it's going to be more professional. Risk. This is the second part. Once we do identification, then we do risk assessment. The organization shall evaluate each food safety hazard. Now remember, pay attention, everything we identified until this point is still a food safety hazard. It's not significant yet. Now we want to see which ones are significant, which ones are not. In 2005, the possible severity of adverse health effects and likelihood of their occurrence is what we use to do the risk assessment. So you take each food safety hazard that was identified and evaluate the possible severity of adverse health effects and the likelihood of their occurrence. And then you put that together and get your risk. And in 2018, they made a change that is really, I'm really happy they made, that clarifies one of the biggest pitfalls in the HACCP system from forever. And that is the assessment of severity. In many opportunities, I've seen cases where organizations assess the severity based on the actual severity in the presence of the control measure. That's a big, big mistake, but it happened often. In 2018, it says we will base our risk on two things. A, the likelihood of its occurrence at the end product prior to application of control measures. So if I'm trying to assess what is the likelihood of somebody getting shigellosis from hand contact with a sandwich, in 2005, people could say, oh, severity is very low. It's low. It never happened to us. It never would happen to us. People wash their hands. People, blah, 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 blah. Well, the question is not that. Prior to application of control measures, the people hadn't been washing their hands. People hadn't been taking care of their hygiene. Then what would be the likelihood? Oh, that's a different story. Likelihood now higher. When we stick to this, we'll be receiving more significant food safety hazards, specifically much more OPRPs. We'll be seeing more of them, because if you ask yourself, well, what would be the occurrence of that specific hazard if I hadn't been doing preventive maintenance? Oh, that's a different question. If I hadn't been doing glass control, okay, now you're talking. So now we'll find out that glass control, preventive maintenance, hand sanitizing, things that previously had an opportunity to go under the radar because of this misunderstanding, the likelihood is now very, very clear. And finally, we did identification, we did assessment, and now the hazard control, the HACCP plan itself. So a new term, HACCP control plan. This is a new term. Okay. Previously, in 2005, item 7.5 was OPRPs, item 7.6 was CCPs. That was 2005. And now everything's been put together into one 8.5.4 called the Hazard Control Plan, the HACCP/OPRP plan. And that's why I said it really doesn't make a difference if you call it a CCP or an OPRP. Doesn't make a difference. You're going to be seeing the same things. Okay. Critical limits and action criteria. CCP. Conformance with critical limits shall ensure that the acceptable level is not exceeded. That's not new. That's always been that idea. OPRP, and this is one distinction, 8.5.4.2, that I strongly dislike. And I encourage everybody listening, all 371 of you, to find a way to disregard this. Because what it says is that an OPRP, when you talk about the critical action criteria, conformance with action criteria shall contribute to the assurance that the acceptable level is not exceeded. Not ensure, but contribute to the assurance. Now, that is wording that is a little slippery, and I don't like it. I don't want anything to contribute to the insurance. I want it to ensure. There should not be a difference, in my opinion. So I'm willing to argue that. The monitoring systems. Let's compare CCP and OPRP. The monitoring system and frequency shall be capable of timely detection of any failure to remain within critical limits, to allow timely isolation and evaluation of the product. That's CCP. That makes sense. That's perfectly true. That hasn't changed. So the CCP is going to be monitored in a way that if we do detect a deviation, we can isolate and evaluate the product and it won't escape from the plant. The OPRP now says, and this is new, that the monitoring should be proportionate to the likelihood of failure and the severity of consequence. So it's a little more loose. Again, because there may be OPRPs that are not part of the process, that are more difficult to monitor regularly. They may be monitored once a day. Then we're saying that we're going to monitor proportion likely to failure and severity of consequences. Give you an example. Let's say I have my glass control. So that we will watch our lamps every day. They're always intact. Don't worry about it. Nothing's going. If it breaks, then we'll know what to do. We'll find out. So we'll do it at the end of the day. At the end of the day, during cleanup, we have a checklist. We'll look to see that all our lamps are intact. If anyone is broken, we'll deal with it because they're not directly above the product. Blah blah blah. Whatever. And that's why we're doing it once a day. That's why we chose our frequency. I would prefer, and if it were my plant, I would treat an OPRP just like a CCP when I talk about the frequency of monitoring. Control of monitoring and measuring. When equipment or process environment is found not to conform to the requirements, then we must assess the validity of the previous measuring results. I want to talk about this for a second. This is new, and this is great. It wasn't written previously. What it means here is that if we have a measuring device, like a thermometer or like a dosimeter or a flow meter or a measuring device, any measure, a pH meter, it must be calibrated, like all measuring devices according to ISO 9001. However, if that verification of accuracy that we do, that calibration, if we find out that our measuring device does not conform to requirements, then we must assess the validity of the previous measuring results. And if we're talking about a CCP or an OPRP, that might mean that if we don't know what the validity of the measuring result was in the last 10 weeks, 10 months, we have a big, big problem. We might be facing a big recall. We might be harming people. So, it continues to say the organization shall take appropriate action in relation to the equipment or process environment and any product affected by the nonconformance. It is our recommendation. Also, by the way, it's a USDA requirement that measuring devices that measure CCPs must be verified at least daily. Okay, this is our interpretation. This is not written in the standard, but it's my interpretation of what's written there. Devices used to monitor CCPs and OPRPs should be verified for accuracy at least daily. It doesn't have to be sent out to a calibration company. You don't have to pay thousands of dollars. Just make sure that every day you know your measuring device is accurate, because the day you find out it's not, you have product on your hand that you can't vouch for. It may have been processed without the benefit of its CCP or OPRP. Control of nonconformities. 8.9. Here is one of the places where I do not like the difference between CCPs and OPRPs, and I wish they hadn't written this. But it's in the standard, so I'm going to talk about it. CCP says when critical limits at CCPs are not met, effective products shall be identified and handled as potentially unsafe products. Simple, straightforward, true, always has been, always will be. If it were up to me, if I were to make the decision, then I would say the same thing. I would say when critical limits or action criteria at OPRPs are not met, exactly the same. I wouldn't make a difference. But the standard writers did give us a little bit more freedom with OPRPs. And the wording is as follows. Where action criteria for an OPRP are not met, the following shall be carried out. 3 things. Determine the consequence of that failure. Determine the cause of the failure. Identify affected products and handling in accordance with handling of potentially unsafe products. Okay? So it's giving us room for thought and less. CCP says, doesn't matter. You can do it. Doesn't matter what were the consequences, what were the causes. It doesn't make a difference. When critical limits are not met, it's identified and handled as unsafe. Well, when OPRP is not met, then you have something to talk about. What are the consequences of the failure? What caused it? Blah, blah, blah. I do not like this, but it is in the standard. Okay. And now we're talking about 894. So what this made reference to is here. I went back. So it says, when critical limits are not met, blah, 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 potentially unsafe products will be handled as potentially unsafe. And here it says, according to handling potentially unsafe, 894 is the standard clause for handling potentially unsafe products. It's what we usually would call the non-conforming product clause. And here also there's a difference between CCP and OPRP that, again, I don't like for the same reasons. So products affected by failure to remain within critical limits shall not be released. Shall be handled according to non-conforming products. Simple, always will be, always has been, no fooling around. You have not met your CCP, you are not conforming. Boom. OPRPs, on the other hand, products affected by failure to meet action criteria for OPRP shall only be released as safe when any of the following conditions apply, and then we have ways to release it as safe. So it says, okay, if you have evidence other than monitoring that the control measures have been effective, you can release it. If you have evidence that combined effective control measures have conformed to the performance intended, you can release it. If you have sampling, analysis, other verification activities that show that the product meets acceptable levels, then you can release it. So you have ways of releasing a product that did not meet its action criteria because it was an OPRP, which you don't get for CCPs, because CCPs are so unequivocal, they're so clear-cut. And it is now on the hour, so my time is up. And I hope you enjoyed walking through. Let me just put on my camera so you can see me. Just walking through the new standard ISO 22000 standard. And again, as I said, you get a feeling of my feeling for the changes in the standard. Some of them I really like, some of them I don't like, and I think it's important for all decision makers in our industry to understand the pros and cons of these changes. On the one hand, clarifying some things that were not clear. For instance, making sure you understand exactly what your food safety hazards are, disregarding the control measures when assessing significance, when assessing likelihood. On the other hand, the new leniency towards the OPRPs is a little troubling for me, and it should be looked at and thought about before you make crucial decisions on how you're going to handle your OPRPs. So that's okay. Am I still there?
You are.
Okay.
Yeah, you are. I wasn't. I'm back. Right. Yeah, we've gone over the hour, and you did answer some questions during the presentation.
Yeah, I just saw a question pop up that I wanted to mention. I can't see it anymore. Somebody asked the difference between a CP. There it is, Mohammed Hassan. Well, Mohammed, sorry to say, CP has retired. CP, Elvis has left the building. No CP anymore. And I think that's unfortunate. But truly, anything that is not a CCP will still be a CP. It'll be a control point because it will be. It's not defined in the standard. I know that the United States Department of Agriculture, the Food Safety and Inspection Services, expect us to respect the CP and the corrective actions for CPs. That has not changed because they have not changed regulation. What I just mentioned was, again, if I said that too fast, the USDA Food Safety Inspection Services in the United States of America still respect the CP, but ISO 22000 has totally ignored it.
Okay. Do you want to hang around for a few minutes on 3 questions, David?
Of course. It's Friday night. Okay. I have nothing better to do. Okay, then.
For those of you who do have to go, I've already loaded the certificate in the sidebar, so you can grab that and go. But for those who want to stay while we've got David here, then let's carry on. Pratui, when we do hazard verification and we find out the CCP has been under control, could we reduce the critical limit or change it to another process that is being critical? And could we make assessment that has no CCP inside it?
Oh, definitely. This has always been true for HACCP, and it still is. We are expected to do what you call hazard verification, of course, will bring us around to revalidation. It's a circle. It's a continuous circle. So we're constantly doing verification and using our verification information to revalidate our processes. And sometimes we'll find out there was something that should have been controlled using a CCP that we failed to identify. And often we'll find out there's something that we have been controlling using a CCP, and it wasn't justified to call it a CCP. We can say it's not anymore. I'll give you one example, and I hope I understood the question. If I didn't, just say no, that's not what I meant. But I think I understood the question. For instance, metal detectors have famously been known to be CCPs, and that aggravates me. I don't think metal detectors should be CCPs as much as they are. If a metal detector is working in a way that it is identifying metal foreign bodies often, the organization should be doing a catch analysis and saying, oh my God, where are these metals coming from? How come we have metal in our product? I shouldn't be relying on a metal detector. It's a mistake. And fixing that in the source. And if we do upgrade our preventive maintenance and upgrade our suppliers and our raw materials, and achieve a situation where eventually we do not have a metal detector may find a piece of metal once every year, whereas it used to find metal all the time, then it's time to reassess its CCP-ness. Maybe it's not a CCP anymore, and we can now call it a CP. We're not going to throw it out. We're not going to stop using. We're not going to stop monitoring it, but we can stop calling it a CCP. That's just an example.
Okay.
So I don't know if that's what you meant.
Robin, can we think of CPs as OPRPs?
No, that's one of the big. I said no. You can think whatever you want, but no, because OPRPs are control measures, and control measures are now defined as something that we do to prevent or reduce a significant food safety hazard, and CPs are used to control and prevent non-significant food safety hazards. So I wouldn't want that you to make that mistake, and just keep all OPRPs as they are defined. That's my opinion.
Okay, Marielle, is there any mention of food fraud / defense in the 2018 version?
The answer is no. However, we saw that item 8.2 points us to that we should, not shall, make reference to ISO technical specification, ISO 22000, ISO TS 22002. That technical specification does make reference to food fraud and defense. So if you add 22002 into your PRPs, then you're getting a more wider risk assessment, including what we call VASAP or TASAP threat and vulnerability assessments.
Okay, for some reason I keep disappearing. I did see a question there. What's the most drastic or dramatic change, in your opinion, from the 2005 to 2018 version?
I think for me personally, the most dramatic thing is that the extension of the definition of an OPRP to include steps in the process that are observable and not measurable. I didn't see that coming. I knew that people they were calling these steps OPRPs. I thought it was an accident. I was writing them up on audits saying that's a nonconformity. You can't call this an OPRP. And now that when the new standard came out, I said, oh, okay, I was wrong. I guess they are OPRPs. So that's dramatic in my opinion, even though it's just a name. But besides that, there's no real drama. In my opinion, the addition of animal feed, of course, is dramatic for dozens and dozens of organizations, of course, because they were outside of the standard before that.
Okay. Right. Irina, if our X-ray is not able to identify low-density bones, what are the possible corrective actions to reply to the supplier, considering that the NCR has been sent to the raw material supplier? It's a bit specific.
I imagine Irina's talking about poultry, I imagine, or fish. I guess poultry. Irina, you talking about poultry? Maybe she can answer me. Yes, no? Are you still there? Anyway, yeah, customer. Well, of course the customer, but what is the product? Is it poultry, chicken?
Irina, is it chicken, fish, something else? Bread products.
Why would there be bones in bread? I'm confused. I would not identify bones as a potential hazard in bread. Breaded products. Okay, chicken. Okay. I guess we mean that we're talking about ready to eat, frozen chicken patties that have been breaded. It would be a risk assessment. You have to assess the bones and see what is the severity, what is the likelihood, and if it is a significant food safety hazard. There are X-ray machines that can detect low-density bones. It's a matter of getting the right equipment. It's not my expertise, but you should contact a foreign body expert, one of the big companies, and they'll be able to calibrate that machinery to be able to identify. Otherwise, we're back to the old-fashioned way of visual inspection of each patty, each fillet. Fillet? How do you say it in English? Fillet or fillet? Fillet?
Fillet.
Fillet? Each piece of deboned chicken breast or thigh, whatever's being deboned, is manually inspected and with not only visually but manually. So the worker puts their hands on it, they pat it down, they look at it, and then it's put through. And it's a highly time consuming and manual process, but that's how we reduce bones to an acceptable level. That's all.
Marvin, what is really the difference of process decision tree from process decision tree in ISO 22000?
Great question, Marvin. I hope nobody would ask it, but there is no mention of a decision tree in the standard. So, whereas Codex Alimentarius is specific about a decision tree, and so is the USDA, ISO has never been. Even in the 2005 version, it just said that the methodology used to make the decision, if it's a CCP or PRP, should be documented. That's not even written there anymore. So I think that we are expected to move a little bit away from the decision tree. Use of decision trees has caused, in my opinion, a lot of it's prevented us from seeing the big picture. We're expecting an algorithm to put in information on one side and get an answer out the other end, and it's much more complicated than that. It's not just the last step in the process. Decision trees were good when we talked about classical, traditional HACCP. You have a process, you have CPs along the road, some of them will be CCPs, and put it to the tree. Now that we have OPRPs and we have what we call combination of control measures, and we're looking at the whole picture, it's a more holistic approach. We have to use our human brains and our judgment, and we cannot rely on the decision trees anymore. We can still use them, but I would not use them in such a big deal. And the bottom line is we must ask ourselves two questions, and that would be the decision tree. A, is the control measure effective in reducing the hazard to an acceptable level or preventing it? Yes or no? If yes, if no, we can't talk about it anymore. We're done. We have to go to something else. If that's yes. If no, if yes, is it monitorable? Can we monitor it to the level that if there is a deviation from action criteria or from critical limits, can we react in time? If no, then go back to thinking about something else. If yes, then you have a CCP or PRP. So it's a pretty simple two question, Q1, Q2. Is it effective? Yes, no. If it is it monitorable? Yes, no. If it is yes, then you have a CCP or PRP. If not, you have to do something else. That's the best I can do.
Very good. Vasilis, is it fair to say that in the new ISO 22000-2018 we have two risk assessments, one for the products and one for the organization, 4.1 and 6.1?
Definitely. Because of the high level structure, then item 6.1, which is the risk assessment in ISO 22000 and 9001, calls for risk assessment. Many organizations will still maintain their ISO 9001 simultaneous to their 22000. So then they will disregard 6.1 in 22000 because they have it for 9001. If you're only doing 22000, you don't have 9001, then you should be doing an organizational risk assessment. However, you're not expected to be looking at quality issues. So if I have a supplier of chocolate, if I have ISO 9001, I will identify the risk of him not being able to supply the chocolate on time. because of a strike in the ports, B, a disease that the cocoa trees get, C, his prices skyrocket. So 3 reasons, and then we'll go through that. It's nothing to do with food safety. It'll be the same question you're asking if you have a sock factory and you have a problem with the supply of wool. So we don't expect that in 22,000. But may he be exposed to more, may the disease that the cocoa trees are experiencing make them use a new type of pesticide that has not previously been used in that industry before. That would be something that we'd expect to see in the risk assessment. And vice versa. There's also, we must be looking at the opportunities, which in food safety risks we don't need to do, in 20,000 we do need to do. So there are opportunities. Is there a new way to validate the absence of allergens that's now been introduced? Should we be adopting that, looking into that? There's an opportunity. So we expect that to be looked into as part of the standard. So did I answer? I think I answered the question. Yes,
Okay.
2 risk assessments.
Yeah, nuggets, David. Nuggets. Chicken nuggets. That's what Irene. That's what Irene makes.
I understand. It should be detectable in X-ray. If it's low density bone, it may not be a hazard. It may just be a nuisance. Because if it's a rubbery bone or a piece of cartilage, then it won't break your tooth. It'll just be a nuisance. It'll be, oh, I don't like this. I'm complaining, blah, blah. So it may be justifiable to have a CCP. But if it is a hard piece of bone that could break your tooth, then the hazard is justifiable. Then you should have an X-ray machine that can detect it. That's my answer.
Okay. I think last one, perhaps, Juliana. Can we consider preventive controls from FSMA the same as OPRPs?
Almost the same, very similar. The difference is that FSMA does not make that specific differentiation between the essential and non-essential, which is the great thing about 22,000. So a preventive control could be hand washing and sanitizing. It will be across the board. Whereas hand washing and sanitizing in a ISO 22000 plant will be different for people who have direct contact with the food and for people who don't. So that we differentiate between our preventive control, our PRP, if it's a critical or non-critical. And FSMA does not make that specific differentiation.
Right, great. All right, we've run a little bit over, but thanks very much, David. It's been very enlightening. There's been loads of questions. I'll just put a link in the sidebar. If you want to go to the discussion forum at IFSQ and post some more questions on there, and we'll get some answers for you. But yeah, on behalf of myself, all the audience, IFSQN, great again. Thanks very much, David. Appreciate it.
Everybody have a great, safe weekend, everybody. And for those celebrating, have a happy Hanukkah.